let's discuss a different method in which we can combine pipelines in grid search. One thing that we'll have to add that I left out here is that after we create this cache directory and we use it for our pipeline, it's customary that we delete it. So that's where this other function comes into play, the rm tree, and we just pass the cache directory. So that should erase it. Okay. Now let's go ahead and talk about an alternative method. Now a pipeline is an estimator and grid search is an estimator. In the previous approach, what we did is that we took this this pipeline and we fed it into our grid search. So we fed it into our grid search, and the grid search has access to modify all the hyperparameters for all the steps in our pipeline. But a majority of the cases, a majority of the time, you only want to modify the hyperparameter for the predictor, that last step in the pipeline. So it may not make sense to pass a pipeline to the grid search. What if we did a different approach? Since a grid search is an estimator, that means grid search could be a step in our pipeline. So how would that look like? So we have our data here. It's going to go through our scalar. And then we have our grid search. I'm going to go ahead and draw a different box here. And then inside this grid search is some sort of machine learning model. In this case, it's just a ridge model. And the black is our grid search. So what if we did it this way? Where the last step is a grid search that is only acting on ridge, and then we use a pipeline to encapsulate the entire process. That's the alternative approach. Now in this situation, grid search is going to only work on ridge. So it cannot modify the hyperparameters, it cannot tune the hyperparameters of any previous transformer upstream. But when we call the fit method for this pipeline, it's going to call fit and transform on the scalar, and is no longer needs to retrain the scalar every time it does. It's investigating, it's looking for the best set of hyperparameters for your model. So let's see an example of that. So we can go ahead and we'll go ahead and grid search. In this case, we're going to pass it ridge. And notice since it's only acting on ridge, the param grid, we don't have to do that name of the step anymore. So in this case, it's just alpha. It's just alpha. I'm going to go and pass the customary value, so it's 5 folds, 2 jobs in parallel, and verbose equal to 1, so we can get a printout of what's going on. Set 1, and then we can construct our pipeline. Let's just call this pipe 2 to differentiate with the previous pipeline we constructed. And the step here is our scalar, standard scalar right there. And the second step will be the grid search. Okay. So as we flow in data, here comes the data. It's going to be fit and transform on the scalar, and the transform data we pass to grid search, and then it's going to invoke fit on the grid search, and then that's where it's going to apply the grid search. At this point, only working on ridge. Since it's only working on ridge and this is not a pipeline, there's no need to modify the name of the estimator. It's simply alpha in this situation. So let's go and run it. Okay, that was pretty quick. At this point, if you wanted to investigate what happened during the grid search, some of the things like the best parameters, best score, best estimator, well, since we have a pipeline, we can go ahead and use name steps. What do we call it? We call it grid search. So then here's our grid search object, our trained grid search object. So we can do things like best params, and it will return me the best parameters. In this case, 26.4. Now remember, you can only do this approach if you want to tune, if you only want to tune the hyperparameters for that last step. If for some reason, which is possible, quite possible, let's say we had 3 steps. We had a scalar, a scaling step, and then we had a dimensional reduction step. We want to reduce the number of dimensions in our model, and then you want to use our ridge model. And if you want to tune these hyperparameters as well as these hyperparameters, then we would have to pass this pipeline to our grid search. So I'm going to import a transformer called PCA, which will apply dimensional reduction, and we'll talk about this model in future lectures. But I'm going to call this pipe 3. Let's say the first step is my scalar, my standard scalar. And then my next step is my dim reduction. Last step is my regressor. My param grid. Remember, it's dim red. Underscore underscore and components. In this case, let's say I want to investigate whether I should keep 2, 3, 4, and 5 and 6. And then I want to investigate alpha as well, so underscore underscore alpha. And I just do np log space from -3 to 3, 10 spacings. Then I can do my grid search. I pass the pipeline, the object I want to, the estimator I want to tune, the param grid, say 5 folds, and jobs equal to 2, and verbose equal to 1, but I want to cache those intermediate estimators. So let me just copy paste this code I have here. I can create a temporary directory, the cache directory. So I set memory equals a cache dir. So what's going to happen is that if during this investigation of doing the grid search, it sees, wait a minute, I already created this estimator. I already trained an estimator with these sets of hyperparameters. I cached the result to disk. I'll go ahead and load it instead of retraining it. Grid search.fit xtrain ytrain, and then make sure at the very end I remove that temporary directory. Okay, raise an error. Let's see what happened. Missing self. Okay, I probably messed up somewhere in these parentheses. Get a little bit hairy here. Ah, there you go. 500 candidates. Okay. There's my result. Let's go and do the best params. And it looks like it said, okay, it's best to keep 6. And the resulting alpha, the best value alpha there was 26.4, roughly speaking.